Hey everyone, we are going to be doing section 5.3 today, which is talking about two more shortcuts on proving triangles are congruent. So just to recap, at the very beginning of the chapter, we talked about when two triangles are congruent, all six parts were the same. So all three angles were congruent, and all three sides were also congruent. And then we were like, okay, well, that's a lot of little pieces to have to prove. And so we've been talking about these shortcuts on proving triangles congruent. And so the first one we talked about was side, side, side. So side, side, side was the one where all three sides had to be congruent to all three sides of the second triangle. Today, we're going to focus in on two new shortcuts, the first being side angle side. It's exactly what it sounds like. You have a side congruent and then an angle right after, and then the next side also congruent. And then HL is going to be hypotenuse leg. And so hypotenuse leg is only going to work specifically with right triangles because those are the only triangles that have a hypotenuse. So let's get started. All right, so the first thing we need to talk about is a vocab term called an included angle. Because when we're talking about side angle side, the angle part of it is really important to be in a specific spot. And specifically, it has to be the included angle. So an included angle is the angle between two specific sides. So in the example here, it says to use the diagram to name the included angle between the two sides, or between the pair of sides. And so on example A, it says segment BC and segment CD. And so the included angle between these two sides would be angle C, of course. All right, let's do the next one. Segment BA and segment DA. So of course the angle in between those, or the included angle, is angle A. All right, next we have segment AB and segment BC. And so in this case, of course, we're looking at this larger angle here. Now I cannot say angle B, right? Because angle B could be the top portion, the bottom portion, or it could be the entire angle, which is what we're wanting. And so for angle B, in this case, we're going to say angle A, B, C. We're going to use all three letters. Okay. So again, the included angle is the angle between the two sides that we're talking about. So that brings us to our first shortcut for the day, which again is side angle side. And so the best way to see side angle side is for us to basically just mark the pictures that you see here in the postulate. So I'm going to skip down to where it says if side RS is congruent to side UV and angle R is congruent to angle U and segment RT is congruent to segment UW, then triangle RST is congruent to triangle UVW. So in this case, you'll see the side right here, and then we have an angle, and then we have a side. Notice that the angle is directly in between the two marked sides. So it's super important that the angle itself is the included angle, or the angle between the two marked sides. And so again, over here, you'll see side, angle, side. And you'll frequently see me label it with an S for side or an A for angle, because I think it helps visually see side, angle, side when I write out the letters. So you'll see that on a lot of my examples. All right, so let's go through and answer these examples. It says decide whether there is enough information given here to prove that the triangles are congruent, and specifically using the side, angle, side congruence postulate. All right, so on the first one, they are asking us, is triangle RQV congruent to triangle STU? Now remember, the order of the letters is important. So as we're checking these, we want to make sure that they're following the right order. So specifically, you can even check the angle. That's probably the easiest thing. The angle that's marked here is Q, and the angle marked here is T. And I noticed that Q and T are both in the right position. So that's one of the things that'll help. I also want to check, is segment RQ the same markings as segment ST, which it is. And then I'm also going to check the third piece, which is the other side. Is QV the same as TU? And it is. So far, the order of the letters is good. Now I want to check on the side angle side portion of it. So I'm going to go through and mark using an S or an A. So of course that is a side that's marked. Down here, this little arc, that represents an angle. And then the next one, of course, is a side. So on the first triangle RQV, we see side angle side. We're good. The angle is directly in between the two sides. And then on the second one, side angle side as well. So I'm going to say yes, they are congruent. There is enough information. All right, on the next one, we have two triangles that are actually touching. They're sharing a side, so we'll kind of see a little bit different thing here. It says triangle EFH, EFH, and then triangle GHF, G, then H, then F. So it looks like it's going in the correct order, so that part's good. Now we want to see, do we have enough information? So I'm going to look at this triangle up here first, triangle EFH. So I see that they have a marking right here, so I'm going to label that for side. I see a little arc right here, so of course that's an angle. And I don't see anything else marked. And so right now I'm kind of stuck. I only have side angle. Now, if it's going to be side angle side, the next side that we would need would be this one right here, right? Because if it's going to go in order, it has to say S, A, S. So that's the only place that the side could be. Now, if you remember back when we did side, 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 we actually saw a problem similar to this where the triangles are touching. So triangle EFH, the top right triangle, has a segment in it, segment FH. But then the other triangle kind of off to the left also has a segment FH in it. And so since they're sharing a side, since they have the side that's the same, then this side here that they're sharing is the same on both triangles. And so we do end up having side angle side on the triangle EFH. And then when we look at triangle GHF, we have side, angle, and then side. And so it looks like, yes, we do have enough information. They are congruent. All right. Ooh, letter C, this one's a little complicated. So we have triangle KLM, so K across to L, and then down to M. And then we have triangle MNK. So it looks like they're going in order, so that's good. Next, let's go ahead and see if we can find some information here. So on the right triangle, or the one at the top right over here, triangle KLM, I see this little arrow. And then same thing over here, I see another arrow. Do you remember what the arrows mean? So the arrows mean that these segments are parallel. So I'm going to extend this side out here and this one as well so that I can see that these are parallel lines. And then I'm going to bring you back to a couple of chapters ago. If you look at segment KM and you also kind of extend that line out, you'll see a set of parallel lines with a transversal, the one going through the middle of them. And remember, on parallel lines with a transversal, that's when we had alternate interior, alternate exterior, corresponding, and consecutive interior. So we had all those angle pairs, remember? And so this angle right here, specifically, and then this angle down here, those angles are actually equal. They're congruent to each other because alternate interior angles are congruent. And so we have a little special piece here that we didn't really see originally, these two angles marked, because of the parallel lines. So anytime you see parallel lines for the rest of this chapter, I want you to start thinking alternate interior, alternate exterior, corresponding, because anytime you have that transversal, you're going to end up with some congruent angles. So I'm going to go back through and kind of erase all this and clean it up a little bit. But what we just discovered is that this angle here is congruent to this one down here. So even though they weren't marked originally, the parallel lines helped us mark those. And then just like on the previous example, we see that the two triangles are sharing a side. And so I'm going to work on the triangle KLM, this one over here. And I'm going to go through and mark with an S or an A on the picture here. So I have an S here for side, I have an angle down here, and then of course a side there. And so I'm trying to think, is this going to be side angle side? Now it looks like it kind of could be, but remember the angle has to be directly in between the two sides. And if you notice, the angle here is not the included angle, it should be right here. And so these cannot be marked congruent because they are not side angle side. The side and the angles are not in the correct position. All right, so next we're going to talk about the second shortcut that we're going to learn today. So the second shortcut that we're going to talk about today is hypotenuse leg. Now, before I get into the actual theorem, I wanted to remind you what a hypotenuse is, and then if you didn't know, tell you what a leg of a triangle is. So remember, this is only going to work if we have a right triangle. So super important to note that this does not work with any triangle. It only works if it has a right angle in it. So that part's really important. Now the hypotenuse is located directly across from the right angle. So the hypotenuse in this triangle is right here. So the hypotenuse is always the longest side, and it is always located directly across from the right angle. And then the other two sides that are not the hypotenuse are the legs. And so this side here is called a leg, and so is this one. So just the two leftover sides, essentially. So if you look down at the theorem here, it says if the hypotenuse and one of the legs of a right triangle are congruent to the hypotenuse and the leg of the second triangle, then the two triangles are congruent. So I'm just going to throw some letters on here real quickly. And I am going to make these right triangles. So in order to use hypotenuse leg, you have to have segment AC congruent to segment DF. That is a must because those are the hypotenuse. But from there, hypotenuse leg just says hypotenuse leg. It doesn't say leg, right? And so you only need one of the sets of legs to be congruent. So you could have segment BC congruent to segment EF, or segment AC congruent to segment DE. So you must have this, and then, so you must have the two hypotenuse, but then from the legs, you can choose either one of the, I guess in this case, the vertical legs or the horizontal legs. Either one is enough information. Now, if you had all three legs, or I shouldn't say all three legs, but if you had all three sides marked, you could still use hypotenuse leg. You would just choose one of them to use like in your proof. Or you could even use side, 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 right? Because all three sides would be marked in that case. Okay, so the next example here, it's a little bit complicated because we've got so many things going on in the picture, but it says between these two, or between all of these picture triangles, you know, kind of rectangle even, it says find two triangles in this picture that are congruent using hypotenuse leg. And so I'm just going to go through and kind of highlight some stuff and see if we can find a triangle that works. So I don't know, let's see here. Let's first maybe look at this triangle here and then this one over here. Just the first two I saw. I'm seeing that they don't have any right angles. And so I don't think we're going to be able to use hypotenuse leg because I don't see a right angle there. So now that I say that, let's look for a right angle. So I see a right angle there and there. And so maybe, let's see, what about this larger triangle here? And just to make it easier, I'm going to bring this down. And then I see this triangle up here. Now, it's important to note, I need to kind of label these a little bit. So this was B, G, and E. So on BGE, triangle BGE, I have an F right here, and I also have a D. And it looks like I have these marked and this one here. And then on the other one, it's very similar. I had a right angle here, and that was ACF. And I had a B with these marked, and I have a H. And it looks like this one's marked. Okay, so as I was kind of marking these, I was noticing something. Do you see how segment BE, it doesn't have the second portion of segment BE marked, like from D to E is not marked. So when I look at segment BE and I compare it to segment FA, I don't know if this portion right here is going to be the same as this portion here because neither one of them are marked. And so I don't think I'm going to be able to say hypotenuse leg. If segment FA was the same as segment BE, I could use hypotenuse leg because that's the hypotenuse right there is FA and BE. But it looks like since those two segments are missing, I'm not going to be able to use that. So we're going to have to start over. Now, I still like how I marked these right angles because I know I'm going to need those to use hypotenuse leg. So let me go back through and mark that. So I'm still going to try to use those right angles, but instead of maybe doing that larger triangle that we were just looking at, what if I do just this little triangle right here and compare it to this one right here? So I'm just, again, going to pull these over and mark them up here a little bit. That was HGF, and it was marked as such there. And that's looking good. And then we have B, C, D. We had B marked there and BD marked there. Okay, so it actually looks like we do have hypotenuse leg here. Right here we have a leg, and right here we have a hypotenuse. Same thing down here, we have a hypotenuse and a leg. And so I do think these are congruent. I'm going to write them as a congruence statement. So triangle, let's say BCD is congruent to triangle. Okay, so I went from B across to C. So that means I'm going to need to go from F to G and then up to H. All right, that'll work. Okay, that was fun. All right, so the next 4 slides are all proofs. These are your flip book proofs. So if you are good right now and you don't really need any help with the proofs, you can kind of just pause and go start working on the homework. If you need some help with the proofs, that's going to be the last 10 or 15 minutes of this video. And again, feel free to skip around. I'm sure you know how to fill in all of the givens. So in fact, why don't you just pause the video now, fill in the given statements for all of the proofs, the next 4 proofs. I'm going to be doing proof number 3, number 4, number 9, and number 10. So I'm doing the side angle side proofs, and I'm also going to do the hypotenuse leg proofs. So if you'll go through in your flip book and do at least the givens on those 4 proofs, that'll help us. And then once you're ready to do the rest of the proof, go ahead and hit play. Okay, so again, I went through and I wrote down all of the givens. I also wrote down the last line of the statements for every single proof. You guys know that what you are trying to prove is always going to be the last line in your proof. So that part is also something that is kind of like a give me points. You know, it's an easier one to get. Okay, what I want you to do next on any proof is once you write down your given statements and reasons, I want you to take what you wrote as your statement and actually mark the diagram based on the statement. So when you wrote down that segment XZ is bisecting angle WXY, I want to kind of like look at that in the picture. So angle WXY is this larger angle up there, okay? Now, when something is bisected, that means that it is cut in half. And so when I cut something in half, that means what about each piece? Well, when I cut something in half, each piece must be equal then, right? And so when you bisect an angle, You're cutting an angle into two equal smaller angles, right? And so what's happening here when you bisect an angle is that the little pieces of the angle end up being congruent. And so the angle on the left side, angle WXZ, is going to be congruent to the angle on the right side, angle YXZ. So that's going to go in our proof next. So anything you mark on your picture needs to be in your proof. So angle WXZ is congruent to angle YXZ. Now, how did we know that these two little angles were congruent? Well, because the larger angle got cut in half, right? It was bisected. And so that's just simply the definition of angle bisector. Make sure that you say angle bisector because there is such a thing as a segment bisector, right? So an angle bisector is what we're looking at here. All right, next in line 2, you guys wrote down that segment WX is congruent to segment XY. So again, I'm going to mark that in the picture. So we have WX and XY. And so right now I'm thinking, okay, how can I prove that the triangles are congruent? I can do side, side, side. I can do side angle side, and I can also do hypotenuse leg. Well, right now I'm seeing an angle, and the only one that we know about that uses an angle is side angle side. And so I'm thinking I see a side here and I see an angle here. Can I show that this side is congruent to the side on the other triangle? Well, of course we can, because we see that they're sharing segment XZ. So I'm going to add that to my proof next. I'm going to say that XZ is congruent to segment XZ, right? It's congruent to itself from the left triangle and the right triangle. Now, the property when they are exactly the same is called the reflexive property. And I'm going to say property of congruence since we have a congruence symbol. All right, so are the triangles congruent? Well, we have a side here, an angle here, and now a side here. Same thing on the other triangle. So I would say, yes, the triangles are congruent by side angle side. All right, let's move on. On the next proof, I want you to do the same thing. If you marked, or if you wrote something in your proof, I want you to mark it in your picture. So you said that segment M is the midpoint of LP. So let's start there. Here's LP, and M is in the middle. What does that mean if M is in the middle? Well, just like when you have a bisector, a midpoint does the same thing. It splits into two equal parts, okay? And so LM and MP must be the same if M is in the middle, okay? So let's add that to our proof. Segment LM is congruent to segment MP because M was in the middle, right? And so that's the definition of midpoint. Okay, and then the second part of the given, it was kind of like in there with it. It says that M is the midpoint of LP and of NO. So here's NO. It's going to happen the same way, right? If NO has a midpoint M, that means that each part of NO is going to be congruent on either side. So we're going to add that to our proof as well. NM is congruent to segment MO. Same thing, it's the definition of what it means to be a midpoint. Okay, so we're going to either use side angle side or side 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 at this point, because if you see in our diagram, we've got two sides marked. So it's either going to be side 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 or side angle side. And if it's going to be side side side, we know that segment LN and segment OP are going to have to be the same. I can't really think of a way to make them the same. I don't know of any theorems that I could use, but I do see a set of angles that are the same. Not marked, but this is old school. We did this several months ago. This angle over here and this angle over here are going to be congruent. And the reason that those are congruent, do you know? It's because they're vertical angles. So the angle on kind of like the left side, angle LMN, is congruent to the one on the right side. I'm going to say angle PMO. And the reason that they're congruent is because they are vertical. And so we have a side, we have an angle, and we have a side. And so again, that's side angle side. All right, we have 2 more proofs and then we'll be done. All right, so again, first thing I'm going to do is take my givens and mark them on the diagram. Just FYI, when you see a triangle that says it's a right triangle, typically the middle letter is the right angle. So right here and right here, I know that those are going to be the right angle. And when you look at the diagram, you can tell that those are going to be the angles they're talking about that are right angles. So I'm going to mark those, of course. And if they're both 90, aren't they the same? Yeah. Okay. Just keep that in mind. All right. Now we're not going to use that on this proof. We're just saying that they're both the same. Okay. All right. So we have a right triangle. The next thing they said was that LK is congruent to NM. So I'm going to mark that. Here's LK and NM. And so since I have a right triangle, my mind automatically goes to hypotenuse leg. So is there a way for me to use hypotenuse leg here? Well, the 2 sides that we marked here, those are both legs. And the hypotenuse would have to be right here. But what's nice is that the hypotenuse is LN on both triangles. And so that second side that they're sharing there is the hypotenuse on both. So I'm going to say LN is congruent to itself by the reflexive property, of course. And so if you look at the picture, we have hypotenuse and we have leg, so we're done. They are congruent by the hypotenuse leg theorem. All right, last one for the day. We had 3 givens. Remember, you take those givens and you mark the picture. So first of all, I'm going to mark my right triangles as a right triangle. Then I have that F is the midpoint of DG. That means if I have a midpoint, I know that the segment on each side is congruent. So I'm going to add that to my proof. Let's see. DE and G. Let's see. DE is congruent to, oh, that's not an E. Sorry, that's an F. I couldn't read it. Okay. I was thinking something was weird. All right, so DF is congruent to FG because of the midpoint, right? So definition of midpoint. And then that was a hypotenuse on both of those. And then also in the proof, they said that DE was congruent to GH. So that's a leg. And so if you notice, we got enough, right? We have hypotenuse and we have leg. All right, guys, I know that was long. Again, I hope you stuck with me through those proofs. And if you did, you have all your flipbook done for these several proofs now. So anyway, if you have any questions, as always, reach out to me and I'll see you soon.